Hello everyone. I welcome you all for the course Manipulated Robotics. It's a theory course, and today's topic is about Euler angle representation. Euler angles convention or Euler angles representation. Okay. So for that, first let me differentiate that with the fixed angle. So let's take fixed angle. Okay. So now I'm giving the sequence. So first, there are two frames. One is A frame. And then B frame, this is the moving frame, this is the reference frame, this is reference frame, this is the moving frame or current frame. Okay. The sequence is first rotation about x-axis, okay, x-y axis, followed by rotation about y axis, followed by rotation about z axis, because here you are moving the current frame with respect to reference frame, reference frame, reference frame. So let's see the picture. Okay, so this is my XA, this is the unit vector, so that's why YA unit vector and then ZA unit vector. Okay, this is A frame. So now we are going to show the B frame. So this B frame is about to rotate. So in this rotate about XA, okay. So since it is the starting point, so this is B. As the result, so you rotate about this one. So you have a angle, so which is YB cap, and then first thing. So here you have a theta one, and then you have in this case. So you have okay. So this is theta one, and then this is my ZB unit cap first representation. Okay. So what is next? Next one is rotation about YA. Okay, rotation about YA means here. So let me draw the same picture. So initially it's a cap, YB cap. Better I think I'll draw in the same picture only so that we'll understand the difference between them. So let me use a different color. So what is the second one? Rotation about YA. So where is YA? So here YA. So here you have to rotate about theta 2. Okay. As a result, it takes the form YB2. Okay. Then this takes the form ZB2. And then here this takes the form XB2. Okay. So this is my second. So what is the third one? Third one is let me take, this. Third one is about Z. So where is Z is for here? So you have to rotate about this by theta 3. So as a result, you have ZP third position, and then XB cap third position, and then YB cap third. So this is about what? This is about fixed angle. So I'm calling this as fixed angle representation, fixed angle convention. Okay, then let's take the next one. So let me take this one, the same thing, XA frame, YA frame, ZA frame. Okay, this is my reference frame. So for this, what I'm going to do is first rotate about XB, then rotate about YB, then rotate about ZB. Okay, so here you understand. So here XA, YA, this. So current frame should be rotated about XB, YB, ZB. Okay, so let's do that. So first one is so here initially both are the same place, so XB. Okay, so this is my first one. So it rotates like theta 1. As a result, you will have YB first change. Then next one is ZB first rotation. Okay, first one we have done. So what is next? Next is you have to rotate about YB. Where is YB here? So along YB you have theta 2. Okay. So as a result you have, so this remains the same. So you have ZB2 is cap, then you have XB cap 2. Okay. The next one is ZB. So ZB, let me take this. Okay. So ZB, so where is ZB? The recent one ZB. See, this is the recent one YB. Then ZB where it is. So here. Okay. So you have to rotate along this. So this is one is theta 3. As a result, you have XB cap third one. Then you have YB cap third one. Okay. So this is how your rotation is. Okay. So here, so X, Y. So did you understand the difference between these two? So what is the difference between these two? Just observe. See here, you can see almost these are all same only, but the rotation is different. See, your YB has different one, two, three different thing, but it is two only. And then here two, and then here also two. Okay. So in this case, so this is rotated about, this is rotated about Euler angles, I mean current frame. So rotation about current frame. So that leads to the meaning, the name is Euler angles. So this is with respect to reference frame. Okay, so that is with respect to the reference frame. Okay, so any doubt? Okay, I think it is clear. So you can compare this. So here you have in all this you have one, two, three. So one, two. So here one X is two lines, and then Y is. I mean, you see the current frame. Current frame here two lines, and then current frame here three lines, and then current frame three lines. Okay, because this is the starting. That's why. Here also X is the starting. You have two lines, but Y is also having two lines. Z is also having three lines. Do you understand? So here in fixed set frame, then this is Euler angle. Okay. In fixed set X, you have uh, two angle subtensions. Okay, but here in Y you have three transformation, three rotation, and then Z also you have three. Okay, whereas in Euler in X2, Y also 2, and Z also 2. Okay, did you see the comparison? So this is called as Euler angle representation. Okay, so now we understood what is Euler angle representation. So let me see the combination. So the combinations are either you can do XYZ or XZY. Okay, then YXZ or YZX. Z X Y or Z Y X. Then here X Y X, then X Z X, Y X Y, Y Z Y, Z X Z, Z Y Z. So these are the various Euler combinations. So we can make 12 combinations. Okay. So in this class, what we are going to do is I'm going to take one from here. I'm going to take one from this category, one from this category. Then let's see. Okay, so let's see the complete transformations. Okay, so let's see the first one, which is XYZ. Okay, so first, so I'm going to show the first one. So what is this? So rotation about that is XB. Okay, XB. First angle is theta 1, then followed by rotation about YB theta 2, rotation about ZB theta 3. Okay. So with this, we are going to discuss how we are going to analyze this. Okay. So here, let me substitute the value. So this is X, so 1, 0, 0, 0, 0. So here, C1 is cos theta 1. Okay, then minus S1, S1, C1. It's only the rotation. We don't need this translation part. And then here, 0, 1, 0, 0, 0. C2, S2, and the minus S2 and C2. Okay. C1 is cos theta 1. S1 is sin theta 1, like that. Okay. So next one is this is Z. So 0, 0, 1, 0, 0. So cos 3 minus sin 3 and cos 3. Okay. So let's multiply this. So this will be 1, 1 C2, C2, then 0, S2, and this one C1, 1, 0, correct. This is also correct. Then yes, okay. So now 0, this is 0 minus minus plus. So it is S1, S2. Then 0, then here it is C1. Then this is 0, this is 0, then minus S1, C2. Okay. Next one is 0, 0 minus C1, S2. Okay. Then 0, 0, S1. Then 0, 0, C1, C2. Okay. Then you have to multiply this. Okay, so you will get the answer as C2 C3 minus C2 S3 and S2. Okay. The next one is S1 S2 C3, S1 S2 C3 plus C1 S3 plus C1 S3, then minus S1 S2 S3 plus C1 C3 minus S1 C2, then here minus C1 S2 C3 plus S1 S3, then here C1 S2 S3 plus S1 C3, and here C1 C2. Okay. So so this is my Euler angle rotation matrix. Okay, so rotation matrix with respect to the Euler angle convention. So let's write the same one, C2 C3, then here S1 S2 C3 plus C1 S3, and then here minus C1 S2 C3 plus S1 S3. Okay. Then here minus C2 S3, here minus S1 S2 S3 plus C1 C3, and here minus S1 S2 S3 plus S1 C3. Then here it is S2. So here minus S1 C2, C1 C2. Okay. So in this we can assume. Okay. So if S2 is not equal to, not this S2, I should not say S2. So I can say like this. So this term is uh, R11, R12, R13. This is R21, R22, R23, R31, R32, R33. Okay. If R13 is not equal to plus or minus 1. Okay. So if it is not equal to plus or minus 1, then we can say what is my theta 2? Theta 2 equal to. So how do I get theta 2? Here. Okay. So this one. So how do I get theta 2? So I can say here you have or here you have S2, I mean C2, then here you have S2. So for the theta 2, I need to get S2 and C2. So I can take either this one. So S2 is R13, or before that one second. So arc tan 2 of sine term is R13, then this term is R11 by C2. So So this is my theta 2. So theta 2 equal to R13. Then if I want to take this, I have to take plus or minus square root of R1 square plus R12 square. Okay. So if it is R1 square, it is C2 square, C3 square, is square root of, and then plus C2 square, S3 square. So sorry, C3. Okay, so this will be 1. So your answer is C2. Okay. So here actually S2 should come, C2 should come. So if R13 is not equal to plus or minus 1, theta 2 is like this. Then let's say theta 1. Theta 1 is here, this term. Okay, so this term is first I need, so this R tan 2 of, this term is R23. So R23 minus R23 divided by C2. If I divide this by theta, I will get S1, comma, R33 by C2. Okay, I will get theta 1. Then theta 3. So here, this term. So first I need sine 3. So R tan 2 of R12 divided by R1, yeah, minus R12 divided by C2 and then R11 divided by C2. Okay. So this is when R13 is not equal to plus or minus 1. Okay. So let's take another example. Suppose if, so this is very important, if R13 is equal to plus or minus 1. Say example R13 equal to plus 1. Okay. So your R13 is what? S1. So S2. When S2 will be 1 when theta 2 equal to pi by 2. Okay, when theta 2 equal to 90 degree, this will be 1. Okay. So when this will be 1, what is cos theta 2? Cos 90 is 0. Okay, so this term, the matrix will be, R matrix will be, first one will be 0. Why? Because cos theta 2, because theta 2 is pi by 2. Okay, so this term will also be 0. This term is 1. And then here you have to check whether you have C2 here. So here the formula is, I think, 1 second. So S1, so S1, okay, so you should have some C2 terms over here. Okay, 1 second, let me check that. Okay, so here S2 is 1. Okay, so it will become S1 C3 and then here S2 is 1 and then plus C1 S3. Let me give some space so that we can analyze properly. Okay, so this is very, very important. Let's go slowly. R equal to, so because of C2, this term will be 0. And then because of S2, this will be 1. So you have S1 C3 plus C1 S3. And then here S2 is 1. Here all, yeah, S2 is 1 means it is minus C1 C3 plus S1 S3. Okay. Then in this row, the C2 is 0, so it will be 0. And then when we substitute this S2 equal to 1, it will be minus S1 S3 plus C1 C3. And then in this, if we substitute S2 equal to 1, which is C1 S3 plus S1 C3. Then S2 is 1, then C2 is 0, C2 is 0. Okay. Or in simple terms, we can write 0, 0, 1. Then this is the identity of sine of theta 1 plus theta 3. Okay. Then this one is cos of theta 1 plus theta 3. And then this one is sine of theta 1 minus theta 3. Okay. So this one is cos of theta 1 minus theta 3. And then here you have, okay, this is the problem. So what is the problem? When you have, or when your angle reaches, when the second angle theta 2 reaches pi by 2, this term will be 1 and then this term will be 0, which means this theta 2, what is theta 2? X, Y, Z means this y axis is locked. Okay, so y axis is locked and then theta 1 and theta 3 are dependent. Theta 1 and theta 3 are dependent. Okay, dependent means we cannot give unique angle. So theta 1 is dependent on theta 3 because they are locked. Theta 1 and theta 3, theta 1 minus theta 3. So theta 1 and theta 3 is not unique, okay? And so this will be, I mean, it has only one, so it is locked. Or I can say, in this, you have your movement only in, so this is x, this is y, z. You have movement only in y, z plane. So here you have movement in y, z plane, okay? So this is the analysis. So let's combine the analysis. What is the analysis we have derived? So when theta 2 equal to pi by 2, theta 1 and theta 3 are dependent. Then theta 1 and theta 3 is not unique anymore. Previously it was unique, it was not unique anymore. Okay. And then since it is dependent, so your degree of freedom is reduced from 3 to 2. Okay. And in this axis you have 0, then you have some terms, you have some term, then 1, 0, 0. So which means you are in this, I mean, your final frame, extra, I mean, this frame existing only in YZ plane. Okay, this is Y, this, and then this one, Y plane, this also existing in YZ plane. Okay, there's nothing in X axis, but it is existing in YZ plane only. Okay, so your Y is locked, Y axis is locked, or it is aligned with Y is aligned with either X or Z. Okay. So these are the problems. So this degree of freedom is reduced from 3 to 2 means that is called a singularity. Singularity condition has been reached. Okay. So let's see one more combination. Okay. So the other combination is, so let's take Z, Y, Z. Okay. So Z, Y, Z. So let's draw the diagram as well. Okay. So here XA and then YA ZA. Okay. So first one is ZA only. So let's take your ZB. Okay, ZB both are aligned. Okay. As a result, you have some angle over here. Okay, so this rotated in theta 1. So you have theta 1 and then this is XA1. Sorry, B frame, moving frame. Then you have YB1. Okay, so this angle is theta 1. Okay, so what is next as per the picture? Next one is Y. So where is Y? Here, YB1. So you have to rotate along YB1 along theta 2. So theta 2 means, so this will be theta 2. This one is ZB2. Okay, so this one is theta 2, which is XB2. Okay, then what is next? Along Z only. So where is your Z? So here. Okay. So again rotate this. So this one is theta 3. So this will be moved to XB3. Okay. So this one will be moved to. So here YB1 and 2 are aligned. So now it is moved to YB3. So this angle is theta 2. So this is the picture. Then since it is Euler angle representation, you have to post multiply. So what is R? So rotation of Z theta 1 and rotation of y theta 2, rotation of y theta 2 and rotation of z theta 2. Okay, so let's put the value. So this one is z. So 0, 0, 1, 0, 0. So it is this one is C1 minus S1, S1, C1. Okay, this is the, okay, this one is 2. So it is 0, 1, 0, 0, 0. So C2, S2 minus S2, C2. Okay, then this one is Z. So 0, 0, 1, 0, 0, C3 minus S3, S3, C3. Okay, so let's multiply this. Once we multiply, you will get the final answer like or I'll take the next page. Okay. So your final answer is, after multiplication, your final answer is C1, C2, C3 minus S1, S3. Then minus C1, S2, C2, S3 minus S1, C3. Then here C1, S2. And then second row is S1, C2, C3 plus C1, S3. Then minus S1, S3, C2 plus C1, C3, S1, S2, then minus S2, C3, S2, S3, then here C2. Okay. So again, in this one can be analyzed. So let's say that. So here, if this one is R33. So if R33 is not equal to plus or minus 1. So what happens? So for theta 3 arc tan 2 of, so here you have sine 3 and this one. So I can say this is R32. Okay. So R32 divided by S2, comma, and then for C3 minus R31 divided by S2. Okay. So this is my theta 3. Okay. Then theta 1 is, how did you get theta 1? Arc tan 2 of. That is theta 1 here, this one. So this one is R13, R23. So R23 divided by S2, comma, R R13. Okay, R13 divided by S2. Okay, R23, R13. So this is my theta 1. Okay, then theta 2 is equivalent to, we have to do something. So here we have C2, so this can be done. So here arc tan 2 of, to get sine theta 2, we have to square this. So R31 square plus R32 square, comma, R33. Okay. So if you square this and add it, so it is S2 square, C3 square, S2 square is S3 square. So S2 square is common, this will be 1. So this will be S2 and then this will be C2. So if you take this, okay. So this is for what? When R33 is not equal to plus or minus 1. Okay. So let's analyze what if the second condition. Next condition is, if R33 is equal to plus or minus 1. Okay. When your this will be 1, when your cos 2 will be 1, when theta 2 is equal to 0. So when theta 2 equal to 0, your cos 2 will be 1, sin 2 equal to 0. Okay. So let's substitute it. So here when you put cos 2 equal to 1, so it will be C1, C3 minus S1, S3. Okay, then here if you put cos 2, so it is minus SC1, S3 minus S1, C3. And then if you substitute S2 equal to 0, it will be 0. This will be 0. This will be 1. And then this will be 0. This will be 0. This one will be, this is 1. So S1, C3 plus C1, S3. So here cost is 1. So minus S1, S3 plus C1, C3. Okay. So if you simplify this, so if R33 is equal to plus or minus 1, theta 2 is 0. So cos theta 2 is 1, sin theta 2 equal to 0. As a result, you will get cos of theta 1, because it is minus, so theta 1 plus theta 3. Okay. Then here, if you substitute 1, then this becomes minus of, so this sine of theta 1 plus theta 3. Then only you will get cos 1 with sine. So cos 1 sine 3 and plus sine 1 cos 3. Okay, then this term is already 0. Okay, okay. Then here, if you substitute that one, so it is S1 C3 plus C1 S3, so it is sine of theta 1 plus theta 2. Okay, then here, if you substitute, it will be cos of theta 1 minus theta 3. Okay, and then this term is minus if you take outside. Okay, minus of S. Okay, this one is 0, this is 0, this is 0, this is 1. Okay, so what did you understand from this? Again, which one is locked? Your the combination is Z, Y, Z. Okay, so your Y is locked. Okay, theta 2 is locked. Okay, but you have this is X axis, Y axis, or Z axis, or I can say current frame is NOA. Okay, so here you have only XY plane. Okay, XY plane, and then your this one is theta 3. Okay, so theta 1 and theta 3 is not unique. Okay, then your theta 2 is aligned with theta 2 means y axis. Y axis is aligned with z axis. Okay, so these are the takeaway from this is okay when you rotate the current frame with respect to or when you follow Euler angle formulation, then you will have a lock. Okay, so that lock is called as gimbal lock. Okay, as a result of gimbal lock, the 3D freedom is reduced to 2D freedom. Since your 3D is reduced to 2D freedom, singularity occurs. Singularity exists. Okay, then theta 2 is always locked. Okay, so this is unique based on that. But theta 1 and theta 3 are not unique, which means theta 1 and theta 3 are dependent. So whenever you operate your manipulator in Euler angle formulation, make sure that you will have Gibbon lock. As the result, 1 degree of freedom is reduced. So your singularity occurs, and then this will be dependent. So make sure that you know everything. Then accordingly, you can do that configuration. Then this is common for all 12 configurations, which we have discussed in the start of the class. So it has 12 configurations. For all these 12 configurations, we will have gimbal lock, singularity, then 3 DOF is reduced to 2 DOF. Okay. Thanks for watching.